Hi all, good morning. So today I'm going to discuss today's LeetCode daily challenge problem, palindrome partitioning. So what is the problem statement? Problem statement is that you are given a string S, partition S such that every substring of the partition is a palindrome. Return all possible palindrome partitioning of S. Okay. So we'll be given a string like A, B. We have to return all the substring on which all substrings are palindrome. So first of all, what is palindrome? Palindrome means if you reverse the string, I will get the input string again. Like for AA, if I reverse this, again AA, input and output both are same. Similarly for ABA, if I reverse this ABA, both are same, input and reverse also. So this is still palindrome, right? So palindrome actually, you can actually observe this like ABBA, suppose. This is actually palindrome. How you are actually checking, we'll check that this is palindrome or not. One way is to reverse the input array and compare position by position, same or not. If any config, suppose ABC, then if I reverse this, I will get CBA. Now in position wise, I will check that all are same or not. Like here A and C different, and so I will check both. I will say that this is not a palindrome, right? So this is one way, and if you optimize it more, like if I can actually find out that like first and last will be same because both will be reverse, first position and last position, then second first and second last, got it? Both will be actually same, A B B A. This will be compared, this will be compared, because after reverse this will be actually checked, because after reverse A B B A, so actually we are comparing position wise, actually we are comparing these two, right? Similarly for A B C, like we will first comparing A and C, actually we are comparing first with last, then B will be compared with B only because only one element are present, odd length, got it? This is actually palindrome, and how we are checking, we expand this, right? Now I am coming to this problem, that what I have to return, like for AAB, this is our input string. So what are the possible substring? Like one possible substring AAB, each substring has only one length, so only one length, it will obviously palindrome. Okay, so this is will be one answer. One possible substring is like first I will try to AA, then B. This is one substring and this is second substring. So this is palindrome, this is also palindrome. So this is one possible answer. One substring I can take A, then AB. But you can see that this is palindrome, but this is not AB. If I reverse it, this will be BA and AB is input, so this is different position wise. So this is not our answer. Any other possibility? Yeah, AAB, right? AAB. We'll compare this. This is AB, so this will be not in our answer. Any other possible way to divide into substrings? AAB, AAB. So this is all possible substring possible. So out of 4, only 2 are our answer, right? Got it? Like AAB, then AAB. Got it? And for this example 2, only one character is present, A. So only one substring are possible, or is a palindrome. Got it? So we can actually, like, after getting the input string, I will try to take the like by recursion, I will try to take the palindromic substring if it is possible. Like first I will check that by taking only A, this is palindrome or not. Okay, this is palindrome. So I will take this as a possible answer. Not sure. If I reached end, then I will say that okay, this substring possibles are A one answer, right? But this is a maybe possible answer state. Now I am trying to take, now I have already taken this. Now I will come here. So I'll check that okay, I can take A. Okay, this is A is palindrome. Then I will come here. I will say that okay, B is also palindrome, so I will take this. Got it. Then I will try to take this with these two. Like first I will take already taken A. Now I will try to take that AB is possible. A palindrome? No, AB is not a palindrome. So I will not do this. Okay. Again I will come here. So I'll try to take 2A together. And okay, this is palindrome. So I'll go to the next. Next is only B are left. So I will check that okay, B is palindrome, okay, B is palindrome. So this is one possible answer. This is one possible answer. Okay. Now I am trying to take 3 together, starting from A. So A, B. So I'll check that this is palindrome. No, this is not palindrome, so I will not continue. If any extra character is present, like for A, B, C, suppose. So first of all, what I will do, suppose A, B, C, then it will be more easy. First I will take A, only one length. Then I will come here B, only one length. C also, then D also. Okay. So this is one possible answer. Now, I will return from the D because there is only one element possible. Here in C, I have two choices. Take only C or try to take CD. So I will come here and try to take CD. So found that CD is not palindrome. So I will not continue. Okay. So from C, I explored all the two positions. Like I can only take C or CD. Now I will come back to B. So B has already explored the only taken B. So now I will try to take to C. Then I will again come here to D. So D I can take, but BC is not palindrome, so this will not be our answer. Right? Again I will come here, then I will try to take BCD together. So this is not a palindrome also, BCD. So I all explored the position starting from B. Now I will come here to A. So I have already explored with starting only from A. Now I will try to explore with AB. Okay. So C actually can present only 1 and D, but AB is not palindrome, so this will be not possible. Now I will try to AB, CD. This is also not palindrome, right? Because I have already starting from C, I will explore the two length. Now I am coming back to B, A. So I will take ABC together and D alone. So ABC is not palindrome, so I will not take. Okay. So actually, recursive way, I will just add starting from current index. I will try to take only one, then A, B, two elements, then A, B, C, then A, B, C, D in this way from the current index. And if it is like A, B or randomly A, B, C, anything is a palindrome, then only I can go to the next available index. Next available index, if I take on already A, B, C, then I will go D because our A, B, C already taken. Okay. Otherwise, we have to take. We have to take try to add the new character A, B, C, D if it is not a palindrome. Got it? Let's see the code. So for the temporary path, I have taken a vector of string. This is actually store all the substring for the current. And if it is an answer, then I will insert the temp vector into our answer vector. Okay. So now I'm calling the helper function solve, which actually passes the string s, input string s, the current index, and the temporary path or temporary substrings, and the answer vector of substrings. Okay. So if I reach the end, if start means I index greater than equals to n, then I have already divided this string into a substring where all substrings are palindrome. Okay, that time I will add the current temp path into our answer and return from this. Else what I can do? Else I have option that starting from the current index, I less than a start size, I can take, like first I'll take A, then AB, then ABC, then ABCD. Got it? That's why I have taken a for loop where actually I'm starting from current starting index and I less than n, I plus plus. Got it? and I will insert the current character into a current string. Like for current string is initially empty, and I will add a. Now check that if it is palindrome. Okay, a is palindrome, the current string. Then I can go to the next available character. So if it is palindrome true, then I will add the current string into our as a partition into our temp vector and call the next resolve function for passing I plus 1. Like I have taken a, so next available will be I plus 1 because this is I index. So then this is I plus 1. So I will start from this I plus 1 and temp vector and answer. And after exploring all the options, I will pop back this substring. Okay, partition, and and at the end return. Okay, so this for loop will first explore the a starting from a, then explore all the things. Then I will take I plus plus, so I will take b. It will actually push b string I si. Okay, now explore all the things. Then I will take a b c, then explore rest elements. Okay, got it? And there's a concept how I am checking palindrome. So I will input will be string, and I will traverse the first and last index. First will be the 0, and last pointer will be n minus 1, and I will check that till I less than j, and string of I is equal to string of j, means first and last both are same till. Like first, after I will check that both are same, then go to the next and go to the previous one for this. That's why I plus plus and j minus minus, because I will shift here, this will shift left. So after return j, that j less than I or not. Got it? If it is j less than I, then I've already found that this is a palindrome. Otherwise, if it's break before that, that time it will give us actually false that this is not palindrome. Got it? So what is the time closure of this? Like there is a recursive function, only one recursive function. So okay, so for there is n option, this for loop which can run n times, and each palindrome time velocity will be while loop. So this will also n time n, big of n, and for each position actually it can be called the helper function will be called. So time velocity will be n cube. Got it? This is n is for number of character into a string, because there is that many actually possible position we can start or end, and this n square is for this first n is for this for loop, because our start ending is the current substring is starting from like a then a b c. So that's why this for loop is taken, and for checking that this current string is palindrome or not, that actually taken also big of n. That's why the time will be in q. Can I optimize this more? Yes. How? Actually, if I pre-calculated this palindrome, that I will already store that from starting any random index, like from I to j, any I to j both are variable. I will store that dp, or suppose dpi comma j is equal to true or false. True means this is a palindrome starting from I to j. False means this is not palindrome, that substring starting from I to j. Got it? If we somehow pre-calculate this, how can I pre-calculate this? Like one observation is suppose a, b, c. So a is always palindrome, b is always palindrome, c is always palindrome. Like for each length 1, all will be a palindrome, right? Because there is only one character and there is no comparison for that. But for length 2, this is for length 1, all are palindrome. For length 2, what is the condition? Like first I will check a, b, palindrome or not. How it will depend? I will pre-calculate this like ba. If it's already palindrome, no matter, it will be false. And for bc, it will be false. Got it? But for AAB, so initially all will be like 3 cross 3. Starting from 0, this is 0, 1, 2, 1, 2. So 0, 0, this will be true because one character. 1, 1, it will be true. 2, 2, this will be also true. Got it? Because one length each. Now I am taking AA starting from 0 ending at 1. So this will be like its character is A, both are AA. So it will be actually true starting from 1 ending at 2. So both characters are different, so it will be false. Got it? Now I am taking as length 3, substring of all length 3, starting from I is equal to 0. So starting at 0, ending at 2. This is length 3. So this is how I actually check that. I will first check that I will take the last two, I will just compare the last two characters. I will check like if I remove the first and last character like 0, 1, 2. So 0 and 2 already removed. Okay. So I will found that if I found that DP 1, 1, okay, the rest element, okay, this is actually palindrome or not, and plus this should be same like A and B, character of string of I and string of J, both should be same. A B, suppose A B B A. Okay, so when I'm trying to take this A, like what are the comparison? Comparison should be the first mean at the index 0. Okay, and rest should be the palindrome already pre-calculated if somehow we have stored this or not. And this compare should be always with our first, right? That's why I will check that string of 0 is equal to string of J, the current index J. It should be same, and dp of 1 comma J minus 1 should be palindrome. Got it? If somehow you store this, then it will be palindrome. Otherwise, if somehow in between it's not palindrome, that will be not actually also not palindrome, right? So in this case, like from 0 to 2, that string. So in between index dp 1 comma 1. 1 comma 1 means this true, and for current A and B both are different, so this will be actually false. Got it? So that time, if any in any position we want to know that from starting from I to J is palindrome or not, how I'll find? I'll find this table actually. I will pass like 1 comma 1 is 1 comma 2 is palindrome or not, 1 comma 2, this is false. Got it? In this table. So let's see the code. So we have taken a dp vector where actually pre-calculate this, pre-calculate substring or not. Then I will compute this. I am computing this, I will explain later. And again I have taken a answer vector and also the current temp. Okay. And I am calling the same function, the helper function, where I am passing the 0 as the starting index, input string, current temp path, partition, and result, where I will actually store all the possible way to substring or partition. And the dp. dp is the, it will tell us that I comma j is any randomly I comma j is true or false. False means palindrome or not. Okay. And then return result. So how actually computing the pre-calculating the palindrome or not? Okay, so n is s dot length. Okay, first of all I told that for each length 1, it will be actually A, B, C, all are actually a palindrome. That's why I'm marking as dp I comma I, like starting from the 0 comma 0, starting from 0 ending at 0. So only one character present, 1 comma 1. Only one character starting from 1 and ending also at 1. So only one character present. So that's why I'm marking as all as true. dp I comma I is true. Got it? And also checking that if also doing the length for length 2 is for length is equal to 2. For length is equal to 2, what will be happen like for A, B, C? I will check the next character is present or not, and also this is same or not. So if next character is present, I plus 1 less than n, okay, next character is present, that time I will check that dpi comma I plus 1 starting from I 0 comma 0 comma 1. So starting from 0 and ending at 1. So there are two character. So that time I will check that current si is equal to si plus 1 or not. Like A and B both are actually same or not. That time it will be palindrome or not. Okay, got it? And after that I will come here for length is equal to 3. And length maximum can be n because the input string is length is n. Okay, now I am traversed starting from I is equal to 0, j is temporary, I less than equal to n minus length, because if I sum of length is 5 and total length, and our current substring length is 2 suppose. So what is the maximum index I can take? 0 1 2 3 4. So I can take maximum 3 4 starting from 3. So this will give by 5 minus 2 by 3. Got it? That's a n minus length and I plus plus. Now I'm finding the ending index. Ending index, how will get? J is equal to I plus length minus 1. This is actually ending index. And I will mark, how I will mark? I will check that Si is equal to Sj or not. The starting index Si is equal to the ending index J. Because this is a palindrome, the first will compare with the last. And how I'll comparing? I am checking the first starting index character and the ending index character, both are same, and also I plus 1 and j minus 1. Like this is I, this is j. So if I compare both of this and rest of element, what will be the index? This will be starting from I plus 1 and I have already compared j. So this will be j minus 1. That's why dp I plus 1 and j minus 1, it will be true or false, it will give. Got it? And this will be pre-calculated. And at the end for this function, this will be same. Previously calculating this is palindrome not every time, but this is in constant time. It will give us that the starting index I to j is palindrome or not. So if I reach the current index greater than equal to s length, so we have already reached the end. So this is our one possible answer. So I'll insert the current path into our result vector and return this. Otherwise, how do I do? I'll start from the current index from a, like a b, right? A B C. That's why I'm a for loop, taken a for loop. I is equal to current index and I less than s length, I plus plus. And I will check the current index starting. This is our current starting index. This is our this index. This will be the input index. And the current variable index is ending at I. Got it? And check that true. DP starting and ending is both are true. Then this is our possible, maybe possible a path to partition this. So I will insert the current substring, like current dot pushback s dot substring, current index starting from index and length I minus index plus 1, and then again call the recursive way where I'm passing I plus 1 because I've already taken starting to I. That's why I'm passing I plus 1 is current result dp and current dot pop back. Got it? So what will time loop of this? So this actually taking for loop actually, this is actually one for loop. This is run n times, and this is another nested for loop. This is also running n times. So time loop will be n square for this. Got it? And for this recursive function, what I'm time loop routing? So this for loop is running n times, and every position will be this for loop will run. So and this dp will be giving currently in constant time. So time loop will be for this n square. What is it? Why it is n square? Got it right? Like for each position, it's running a for loop which is range is n. And how many positions are there in the string? N, because n character are present. That's why n cross n. Got it? Thank you.